Mr. Sanju led a team that helped clients evolve their ideas into products, one of which was critically acclaimed in CES Las Vegas 2015, followed by a successful Indiegogo campaign. Sanju is an avid participant in national level hackathons, and his team was crowned as runner up for Intel IoT Hackathon 2015 and winner of Intel AI Hackfery 2 2019. He was also recognized by Intel as an Intel Innovator and as a top innovator for 3 times in a row and continues to hold both titles. So now today we have him to interact with us on the topic building bionics. Over to you, sir.
Thank you so much. I hope everyone can see me.
Yes, sir.
Okay. So,
Yes.
hi everyone. I hope some of you guys might know me. Some of you are new to the session. So, Bionics is something that I talk a lot about. So, if you have heard me talk about Bionics earlier, then the good thing is that you might have more questions this time around. And before I start the session, I wanted to say a couple of things which I normally do on all my sessions, just to make sure that we are on the same page. So the first thing is that whatever I'm going to talk about today, that's the way in which we did things, and I'm not saying that that's the right way to do it or that's the best way to do it. But then even when we were working on these projects like Bionic projects, we had zero knowledge on where to start, how to go about it, what is actually happening in a Bionics system. So the normal, plan of action was just go ahead and start building it, and then through a trial and error method, just learn things and improve it, and thus evolve. So that's the reason why I said that. I'm just an electronics engineer, and even my master's was in signal processing. So I'm not a robotics engineer in any sense, but you keep learning. So the next thing is. The objective of the session, so I had a discussion with Lainey ma'am. So the objective of the session is for me to show you how you can start, working in the field of bionics, especially, and if you have zero knowledge of electronics or electrical systems or anything or robotics per se, or even if you have zero knowledge on microcontrollers, don't bother about it. Because whatever I'm going to tell you is, yes, there is technology involved, but believe me when I say that these are things that you can also build, because otherwise I would be lying to you. So if it was really hard for you to build, then I wouldn't say that you can build it, because that would literally waste your time. So whatever I'm going to show you is something that you can also build, but you have to dedicate some time to it. You have to put some effort into it. And then I also thought that it is best if I can share some of the things that we have done, so that you don't have to go through it again. You can start from a base, from where we stopped, if you can do it, and then do something better compared to what we have done. So yeah, those were the two things that I want to say. I'll get straight away into it, because I don't have a presentation. That's not how I normally do webinars. If it was a face-to-face, one-on-one interaction, we could have made this a whole discussion-based system. But right now, because that's not possible, what we can do is, I'll talk about where we started. I'll talk about how we stopped midway, then how we took it back a couple of years later, and then where is it right now. And if you have any questions, please post it on the chat section, and our moderators will be able to pass it around to me. Okay, cool. So back when I was at college, I always wanted to build something, especially after the fact that my seniors gave me a Arduino microcontroller session. And the most fascinating thing for me after that I learned through that session is that now I have the power to control things. Because it was just the first program that we ran was just blinking an LED. But the thing is, it opened up new doors where now if I can blink an LED, if I can control an LED in the way in which I want, then I can probably control a whole lot of things. I can control a motor. I can, it's just 2 or 3 lines of code, but the amount of power that it gave you was too high. So it was, I still remember this happening during my second year at college, and it was a very small session. It was a 2 day workshop kind of a thing, and then they showed us how to blink an LED, and then we just went crazy from there. Every one of us started, doing one or the other thing with it. Now the thing is, when we started, coding microcontrollers, we had zero knowledge on what embedded system was. We had zero knowledge on how to build electronics, circuits, what are the things that we need to look out, and we had zero knowledge on how to design power supply systems. And when you look at it, these are kind of like different areas of engineering. So coding, you can say that it's a computer science thing. The power supply part, you can say that it's electrical. The electronics part, obviously, is electronics. And then if some robotics thing comes in, you can say that it has something to do with mechanical and so on. And if some automation, home automation thing comes in, then maybe civil also comes into play. But then the funny thing is that if right now when I look back, if you have to work on a project or a product, it's best if you actually need a good amount of knowledge in all these areas, because fundamentally you are an engineer, and then your specialization might be in electronics engineering. So back when we started, we had zero idea about any of these things. We thought that everything is electronics, and you have a microcontroller, you put some code into it, and then it will work. You attach a motor to it, it will just work magically. And then we started doing it, and then we realized that there is something known as power, which is voltage and current. You need the right voltage and current to actually work a motor. And then my team, we embarked on this new concept as in for us, it was a new concept of building a really cost-effective bionic hand. And this was, I think, third year of college. And I have no idea what we were thinking back then, because we had zero knowledge of what Bionics was, and we had no idea how to design electronic circuit. We had no idea how to. The only thing that we knew at that point of time was to connect an Arduino and, type a bunch of code in, and we can control LEDs and we can control motors, and that too DC motors, not stepper or servo or those complex kind of things, just DC motors. You can maybe turn it clockwise or anti-clockwise. That's it. So just checking in, am I audible to everyone? Oh, okay, cool. So as I said, when we started these things, we had zero knowledge of all these things, and then we so naively thought that we could, in a matter of months, we could build a bionic hand. And the funny part is, a bionic hand is not just an electronic system. There's a huge amount of things that gets added to it, because there is a for to start with, you need to build the entire hand, right? So we had no idea how to do this, and and back when we were at college, 3D printing was not available, or it was not easily accessible. It was not until maybe another 2-3 years that 3D printing became a thing. We knew that 3D printing was there, but it wasn't accessible or cost effective. So we had no idea how to build it. The thing is, one day we were in our, and this was our main project. And one day we were at our friend's house, trying to figure out how to build the physical bionic hand, and we had a Pepsi can lying around. And again, this is a level of naivety that we had, or in a sense, I can say this is this is where we were at that point of time. We had zero knowledge. When I say zero knowledge, we literally had zero, almost like maybe we had 0.5% knowledge on how to code a microcontroller. And we had a Pepsi can lying around, and it was empty. And then we did cut sections of the Pepsi can, and you get these small metal strips, and using the metal strips we model something that looks like a finger. I have no idea why we did that, but that was literally our first finger. And even then we had no idea how to, actuate a finger, even if we, end up making it. Because at least for me, the physics didn't really, work in my head. And, so let's say that I build something like a three-section finger. How do I, and then I have a motor that will turn clockwise and anti-clockwise. How do I, open and close this finger? It wasn't, the physics wasn't very clear to me. And this is after the fact that I went online and researched on it, and I saw that all you have to do is attach a string over here, attach another string over here. If you pull this string, it will close. If you pull the other string, it will open. So it was there. I read it, I saw it in action, but I still can't figure out, because I was always thinking if I attach it and if I pull down, then if it is closing, then maybe there is a strain over here. How does it close? Will it close? So this is the level of confusion that we were in. But then we were so driven by the fact that we could build something, interesting, and we could build something that would, look cool. And the reason why it would look cool is that this is not something that everybody would do, because most of the people will be like, yeah, let's do, it's our main project. There is a mark associated with it, internals and those kind of things. In your case, maybe credits or something, I don't know. So, but then we never bothered about it. I have no idea why we never bothered about it, because this was never meant to be a main project. This was kind of like a side project, and we used to do that all the time. Whenever, and if you look at my college attendance, you will see that my last year's final year college attendance would be something around 98% or 95%. It's not because I wanted to study so desperately. First thing is, I loved my class, I loved my friends, so it was always fun being with them. Second thing was, we were always at college working on some IEEE, project kind of a thing, and we always have some electronics thing to do, or the thing that I remember, the most weird thing that we thought of building was a big catapult on top of our college for crossroads. So again, completely on the civil side, on the civil department side, we had zero knowledge of how to do it, but we were just thinking about it. So that was my college time, where we had a lot of side projects, and one of those projects was this Bionic Hand, where me and my team, my mini project team, we thought that let's go ahead and build it, and we started working on it during our third year. And that's why I said that it was never a mini project kind of a thing. It was like, if we build this, it is cool. If we build this, and if we could make a really cost-effective Bionic Hand, maybe it's good for the society. And as an engineer, that's something that we would always love to do. So fast forward, we started building the Bionic Hand, and then, as I said, we had no idea how to build the hand part. Then we thought that, okay, let's go ahead and build the electronics part. Now, when we started working on the electronics, things became more and more clear. You know what's the first thing that we built? We just had a microcontroller. We had 5 motors, assuming that it's for 5 fingers, and then we connected everything together, and it didn't work. Then I then realized that yes, the motors need a driver circuit, because it takes more power. It needs more power to run. So I was like, yeah, let's just build a small driver circuit. We built it, and we tested it with one motor, and it was working almost perfectly fine. And at this point, we just naively thought that, okay, microcontroller is working, code is working, motor is working. Let's just go ahead and think about the rest of the thing. So if one motor is working, obviously all other 5 motors should work, theoretically. And so we went ahead and started thinking about what this Bionic Hand should be. So that's where the ideation is actually starting. So it wasn't a case where we started ideating, we had a full-fledged plan, and then we went on to, build it. It was the other way around. We just wanted to build it. So we didn't even think of anything. We just went ahead. We had a microcontroller, we had a motor. We just, it was the other way around. And then we started ideating. And when we started ideating, we started researching a lot about Bionic Hands. And I don't want to get into too much details of it, because as I said, the objective is that I want to show you what we build and how we build it, so that maybe even after the session we can have a good discussion about it. And even if you are a person who wants to start, maybe this session is good for you. So we started, figuring out a lot of things about Bionic Hand, and then we finally came and said, okay, this is a Bionic Hand that we need to build. Obviously, it needs 5 fingers. The wrist motion, not exactly required. Let's just, not do that. It's too much. It's too complex. We haven't even figured out how to build the, physical hand. So we have 5 motors, and then how do we control the Bionic Hand? And when we looked online, we saw that there were a lot of ways in which people were, mapping their left hand. So if a person is amputated only on the right hand, then you can put something known as a smart glove with flex sensors on your left hand, connected wirelessly to the bionic hand, which is a right hand. And then whatever you do with the left hand gets mimicked on the right hand. But then, in a sense, at one point of time, you still have one hand, right? Because the other hand is just mimicking what the left hand is doing. So we don't want to go with it. Plus, more electronics. We don't want to add more and more electronics into it, because we are still yet figuring out how to, build the electronics for the Bionic Hand. And do remember that all this is happening while we were at college, with all the assignments and all the other things, pink slip and everything going on. You know it. You know the drill. So we started, figuring out. We started working on what is the other way in which we can build bionic hands. And then there was this DARPA hand. DARPA is a defense and research project for U.S. Military. They have this very cool DECA arm. It's a full arm, and it was controlled by pressure pads that is put under the feet of a person. So you're literally like pressing buttons on a keyboard, but you're doing it with your feet. And you can precisely control everything. We went with it for some time, but we figured out that we couldn't actually understand it completely to give a natural way of controlling the hand. And when I say natural, it is, it's again funny, because what we ended up doing was not very natural. So what we ended up deciding was, we thought we'll build a speech recognition unit. And that's not a software speech recognition unit, it's a hardware speech recognition unit. So no AI, nothing. So we thought that we'll build a speech recognition unit where we will first store commands. And whenever we say that command, there will be some output from the unit that the microcontroller can interpret and, and control the fingers. So this is what we built finally. And as you can see, it's a completely hardware-based unit with a couple of clock and with a display unit and a keypad. So how this works is, there is a training mode where you can, if you click on, so this is the train button. And if you click on the train button, then it'll ask you. It won't ask you, but you know that the process is, when you click on train button, then you have to enter a number. So you will press train, you will press 01, and then you will say a number, you will say a command like open, and then you will press train again, which means now when you say open, the number one, binary of 1 will get output, and then will get outputted from the system, and then the microcontroller can detect it. So we started adding, and you can add 20 commands to it. So we started adding commands like open, close, stop. So open means everything will open, close means everything will close, stop means it will stop wherever it is. So if it is closing and I say stop, it will just stop right there. So we built the entire thing, and it actually worked. The speech recognition unit worked, and then we started piecing everything together. And then came the reality moment. So this was when we enrolled for Manorama Yuva Mastermind. We somehow we got through to the finals, and then the scare started coming in, because Dr. APJ Abdul Kalam was coming for the finals, and we were like, we are going to present this thing in front of him. So you better do something really good, something that looks good. And you just had 1 month.
You just had 1 month to piece everything together, and then this was our final year. So by the time we ended up at this stage, it was already our final year. It was December. We had 1 month to build the entire mechanical part, and at one point we were also like, we might not be able to do the mechanical part. Let's just show 5 motors being controlled, so that we can say at least if this motor goes this way, it means that particular finger is opening or closing. Stupid things. I have no idea why we thought about that, why I thought about that. But then we started, at this point of time, we knew that we couldn't do this alone. So we started connecting with people. We started connecting with people who are creative to understand how they would do it. And then we got in touch with a guy who said that there is a very easy way to do this. You can just Lego things up, which means, so if you have used Lego, it's just building blocks, right? It's a 2D building block where you stack together and create a 3D model. So do something like that, but instead of a Lego, use a 3D, use a laser cut acrylic plastic. So acrylic is, yeah, I'll show it to you. So acrylic is kind of just like it's another plastic thing. You can 3D print, you can laser cut, and you can laser cut different parts, glue it all together to actually look like a finger. And so we started working with him. He helped us a lot, and then finally we designed and 3D cut, and then glued everything together to create a Bionic Hand. Our very first version. If you can see this, this is what we built back then as during our fourth year, and you can see that there are around 5 motors, and then each motor is attached to a finger, and there is a nice sound to it if you can hear it. That feels very sci-fi the moment it starts working. And even if you look at the strings that is being used, that's actually a tennis racket string. We had no idea what to use. The thing is, you can't use a tennis racket string because it's very elastic. So you lose a lot of power from the motor to the finger. You lose a lot of power, and over time it tends to get stretched out. So your finger won't move properly. It will just sag a bit.
Excuse me, Sanju,
So
you're
this is
showing
what we
something?
built it, and if you look at each of the individual pieces, you can see that this is one piece glued to another piece, glued to another piece, and this right now, I think we had to use around 160 pieces all glued together to build this back then. And it was we never thought that it was a race against time. We never thought we'll be able to make it, but finally the Bionic Hand is done. The hand itself is done. Now to the circuit part. And the most stupid thing that I've ever done is that while I was building the circuit, I completely disregarded the power supply. So if you remember, I told you that we tested it with one motor, right? And it was working. But the thing is, right now we have 5 motors, and if and one of those motors will take a minimum of 500 milliamp current to maximum 1 ampere to properly work. And 1 ampere is drawn especially if there is a load attached to it. So in this case, there is a spring attached to it to the finger, so there is a load at the other end, and so it will take more current to actuate the finger. And we already have 5 motors, and then we had no power supply. I'll show you what the power supply was. And then we soldered everything together. We had a driver IC and all those things. We soldered everything together. We finished up the code. Theoretically, it was all good, and we switched on the Bionic Hand, and then it started acting weird. And the problem was the entire power supply. We were just using batteries which would output only 200 milliamps, and the entire Bionic Hand needs at least 5.5 amperes. So 200 milliamps is actually what we are providing, and then the system is trying to source in 5.5 amps. Huge misalignment. And what ended up happening was the microcontroller will start, it will be happy, it will start, start controlling the motors, and the motors will try to draw a lot of power, and then microcontroller will lose power, which you electronics and electrical people, you guys might learn this as loading effect, and then the microcontroller will restart. So if you look at a laptop or a very well engineered desktop or a laptop system, they already have a lot of things built in to mitigate these kind of issues. For example, in your laptop, if you have a very old laptop, if the power supply is really bad and if the battery is also dying, then you have these kind of issues. The battery or the power supply won't be able to source enough current to actually control the entire system. And in that case, the laptop will automatically power down to a lower, gigahertz. And that's why older laptops sometimes would feel very slow at times. It's not because of virus or any of those kind of things. There's a whole lot of hardware degradation going on. Okay, so we had zero understanding of power supply back then. We had zero knowledge of what was happening, and fortunate enough, by the time it was almost ready for display, we figured this out. And by that time, we didn't have enough time to design a power supply properly. So we ended up just actuating I think 3 or 4 fingers, not all 5 fingers. You can actuate max 2 fingers at a time, not everything at a time. So we had a kind of sequencing going on. So if you have to open everything, it will open one by one. So what you call as a jugaad or a workaround. And I'll show you how the entire circuit looked like. It's a mess. It's a huge mess, and very bad wiring. And this is actually the driver circuit. And you know what's the power supply? It's just this battery. It didn't even have a power supply to start with. The battery was directly connected to the driver circuit. And this was the messed up thing that we built back then. It looked very cool back then, but yeah, it was messed up. But I'm always proud of what we have built, because we had a race against time. We took something that we literally had zero knowledge of, and then we built a working prototype. Now, once this was done, the speech recognition module and everything is done. Now the focus fell onto how can we make this more closer to a bionic hand. Now when I say more closer to a closer to a human hand, when I say more closer to a human hand, you might take a lot of things for granted. For example, when you're picking up a bottle, you're actually calculating a lot of things. You're actually calculating the weight of the bottle. You're calculating if the bottle is slipping, what is the power that I needed to, the pressure that I needed to put on the bottle so that I can lift it up properly. And over time, when you pick up bottles, you get a sense of like, yeah, a 7-Up, a 500 ml bottle will weigh this much, or the bottle that I take to college or to office will weigh this much. So that's a learning that we do on as and when we start using it. So when it comes to a bionic hand, you don't have that sensory feedback. It's just a dead thing, and the user have no idea what is the pressure that the bionic hand is putting into it, or what's the or a feedback on how hot or cold that particular object is. So what we ended up building was we added 2 more sensors to it, and the first sensor was a pressure sensor. So it's a very very cheap resistive pressure sensor, which basically works like this. If you put pressure on it, the resistance changes. So you can, you can detect that using a microcontroller, and you can inform the user maybe through a visual, indicator like LEDs. So you have 5 LEDs. If the user is trying to hold something, and if there is, and as the pressure increases, so as the hand is trying to close more and more, the pressure increases, and the number of LEDs that turns on also increases. So you get an idea that, okay, the user can look at the hand and say that, okay, the pressure is increasing. I should probably stop because I'm holding a water bottle. So if I apply a water bottle without water in it, so if I apply more pressure to it, it might get crushed. Or I'm holding an apple. I don't need more pressure than maybe 3 bar. So that's how we initially thought of building it. But the problem, we didn't want to do it that way, mainly because, personally, we didn't want to look at a bionic hand and then, see a LED bar going up and down, and then, command the bionic hand. Again, what is a much better way to do it? A much, natural way of doing it. And what we implemented was a vibration motor. So the concept was, as pressure increases, what if we, control the vibrations of a vibration motor and attach that vibration motor to the user. So as pressure increases, vibration also increases. So the user doesn't have to look at something or look at a visual indicator. He can just, he or she can be looking the other way, trying to hold something, and then, they'll get a sense of how much pressure is being applied. And over time, as you use a Bionic Hand, you'll get a feel of, what is the pressure or what is the vibration level at which I need to I need to command the Bionic Hand to stop closing. So it's just like, when you started using your mobile phone for the first time, it was a bit hard to type, and then now over a period of time, now you can speed type. So there is a learning curve to it, but this was better, at least in our sense, than the LED thing. And then the next thing was obviously temperature sensor. We just added a LM35 normal temperature sensor, connected it with the Arduino microcontroller, and then added, and for that we said it's okay, we can't add two vibration motors, and that will make things confusing. For the temperature part, first is I can look at something and say that if it is hot, because I can see that it is piping hot or not. And even if I misjudge something, and if I try to pick a hot thing, and the reason that I didn't want the Bionic Hand to pick up something hot is because it's acrylic. So, acrylic or plastic, if it is too hot, it might get damaged. And so we thought that because the entire thing is made of clear plastic, why don't we add a bunch of LEDs to it? So if it is very hot, it will light up in bright red. The entire hand will light up bright red, and if it is cold, or below a particular temperature, it will light up in blue. And the thing is, this is when, as a product engineer, we failed in a sense, because when you light up these many things, it takes a lot of power, and if it is a battery run thing, it'll just the battery will just get emptied out like that. But then back then it was a POC, a proof of concept. We just want it to look cool. We just wanted to add as many sensors as possible, literally, and make sure that we cover all aspects of making taking the Bionic Hand closer to a human hand. And that's what we did. And then after that, we finished up everything. That's what I've shown you right now. And after college, almost when college was ending, we did one more thing, where we just look back at what we built, and we started asking, what can we do better? So for example, right now it is being controlled using a speech recognition unit. So what is there any other better way to control a Bionic Hand? Right now the power supply obviously is really bad, so we need to build a proper power supply controller electronics thing. Then again, the Bionic Hand was made of acrylic, so it is very fragile. So if I can really crush it with a little bit of force, so it's very fragile. So what are the other ways in which I can build something solid? So these were the questions that we asked, and we came up with something called as a future enhancements report. I remember we even submitting this to college for apparently no reason. I have no idea why. So back then, we came up with a future enhancements report, where we said, for creating a Bionic Hand that is actually close to being usable, first thing, you need to build it with something really strong, something like a 3D printed Bionic Hand, or normally a plastic kind of thing, rather than just gluing together acrylic. That was very obvious. Second thing is that rather than using a speech recognition system, because the speech recognition system was good at recognizing speeches, but it would also recognize commands from someone else. It was that kind of a problem was there. So we should use something a bit more natural, like EMG or electromyography. I'll get to EMG later. And then we said that once all these things is done, we also need to look at what is the downside of those really expensive Bionic Hands that we have. which again also works with EMG. So these were a couple of things that we looked back and we did a future enhancements report. Then after that, I went on with my work. I went on with my electronics freelancing and a whole bunch of things until maybe like 2 or 3 years later, I thought, yes, maybe it's time to take the Bionic Hand back up again. So before I move on to that, we are also already past half an hour. Uh, if you have any feedback, if you think that I'm going really fast, or if you think that I need to, before I move on to the next part, if you want something clarified, maybe yeah, we can do that right now. So anyone has any questions, or I can move forward?
So you can move forward. I think someone have
Okay.
fixed it.
Okay.
Okay, sure. So, um, this is where a couple of years later, we actually revisited the Bionic Hand part, and that's when we thought that right now there are a lot of things there. So by the time we finished up the Bionic Hand, and maybe in a couple of years, we were always thinking about the Bionic Hand, even though we didn't work on it. We didn't literally have time to work on it. But then by the time we started the second version of it, we had a fairly good understanding of the downsides, or of what we, or rather I would say what we need to build. For example, now we knew that rather than focusing on the mechanical part of it, let's focus on the electronics part, and let's focus on the control part, and also focus on a new thing. I'll get to it. And that's what we did. But then the first thing that we did was we did 3D print a Bionic Hand, a whole Bionic Hand. But then we didn't waste time by going out and learning a couple of different things. We already had the knowledge to create 3D models and stuff, because we were already building 3D printed 3D printed casings for a couple of our other projects. So we had knowledge of it, but we knew that if we were to build a full-fledged Bionic Hand, the amount of in literally the amount of mathematics, or that has to go in, the amount of calculation that has to go in is too high, because whenever you're building something, there is a golden ratio proportion that you have to meet. And even if you are slightly off, like if the actual calculation is 3.6 let's say centimeter, even if it is 3.7 centimeter, that makes a huge difference, because it just goes exponentially bigger going forward. So those kind of things we knew that those kind of things were there, because we were researching a lot. And so we ended up deciding that let's not build the 3D printed model ourselves. Let's just use a open source available model, and then tweak it to what we need. So we took a bunch of different 3D models, we tweaked it, we made a lot of changes, then we started experimenting with different materials, because in a Bionic Hand there is a lot of strain that is going on. So over here there is a lot of strain that is going on at this portion where the motor is connected to the string using a drum. So you can see that there is a drum kind of a thing. So it's a normal pulley that you see in a lot of places. It's just a pulley where you have a string attached to it, and the two ends of the string is attached to two ends of the finger. So when the motor starts working, this drum part is very most of the strain comes on this drum part. So we experimented on a lot of different materials like PLA, ABS. Then there was this new material that was coming out, which was flexible. So that's the effort that we put in for the Bionic hand model, where we experimented a lot with the with different materials, and we tweaked existing models to what we need, and we finally 3D printed the entire thing out. And this is the final version. I've shown this a couple of times, but right now I'm actually working on this right now. So you can see that even everything is just, it's not in good shape because I've been working on it. I've been rewiring a lot of things. So everything is just disconnected as we speak. This is the model that we built back then, and even you can see that there are a bunch of different materials. So this is one material, this white thing is another material, the black one is another material, and if you look at the drum, again, the drum has one material, and this is another drum with a completely different material. So, and because we chose to do it this way, the 3D model was done really fast, like extremely fast. And even though we had to shell out, I think it was around 40 to 50K for 3D printing the entire thing. So even it was expensive at that point of time. And once that was done, we started focusing on two things. First was the control part. So if you remember, told you that there is this electromyography or EMG system that we wanted. So for those who are not familiar with EMG, EMG or electromyography, in very simple terms, what I can say is when you are opening or closing your hand, there is a signal that is going from your brain to your central nervous system to your peripheral nervous system, which then gives that signal to each of your muscles. And that's how you open and close your fingers and do all those movements with your hand. And EMG is a device, electromyography are those muscle signals. And by building an EMG system or a sensor, what we can do is we can attach it to on top of our skin, on a muscle. You don't need any surgery or any kind of those things. You can just build an EMG sensor. You can attach it to a muscle, and then you can connect it to a microcontroller, and you'll be able to extract those EMG signals. So for us, it was, in a sense, it was magical, right? So because you are literally controlling a Bionic Hand with your mind. That's what we ended up fixing. So we said, yes, we are going to build an EMG system. Now the problem with the EMG system was you have 5 fingers, but you can only acquire a good signal from 2 muscle groups. All the other muscle groups are embedded deep within. So an ideal scenario would be 5 EMG sensors that will pick all the muscle signals correctly and then attach it to each 5 of your fingers. So 5 signals connected to 5 fingers and everything works like a charm. But the problem is that right now we can only access in really good access really good signals from 2 muscle groups. Everything else is embedded deep within. So the best way to acquire signals from those muscle groups is to do a surgery and then add micro needles to your nerve and all those things. So you definitely understand how costly it is, and that you have to go through a surgery. So the problem is you have 5 fingers and you have 2 muscle signals. So it's literally like controlling 5 lights or fans using 2 switches. So you have to put some logic into it. Like if I activate this particular muscle, open all the fingers. If I activate the other muscle, close all the fingers. If I activate both muscles together, maybe do a thumbs up. So that kind of a logic or a template needs to be added in. And the thing is, when we started researching on the Bionic Hand that is available, almost all those 20-30 lakh Bionic Hand works in the exact same way. There is no high-tech thing going on. They also have 2 EMG sensors, and they have a touch button where you can select profiles. So one profile would be just an open and close. So if I select an open and close profile, then if I activate my muscle, either of the muscle, it will just do an open or it will just do a close. Then to do a thumbs up, I'll just switch it to a thumbs up profile. Again, activate the same muscle group. It will just do a thumbs up and then a close. So this is how the Bionic Hand was working. Now the another problem with this is, first, you are restricted. It's not a very, very natural way of controlling, but then it's close to it. But the second biggest problem was that these Bionic hands comes with, let's say, 14 templates. So you can do an open and close, you can do a thumbs up, you can do a maybe a victory sign, I guess. You can do a pinch grip, you can do a key grip. Some common 14, templates is what it comes with. And what if I want to do some gang signs like this or something? You can't do that because yes, it's a costly Bionic hand, but you'll have the company needs to throw out a software update by which you need this new thing to get added in, new template to get added in. So we thought that maybe there is a different way of doing it because we clearly have an app store, a Google Play Store and an iOS App Store. So why don't we build a market, a Play Store kind of a thing for a Bionic hand? So that's where the entire thing started, and we named it as Evolve because we always wanted it to evolve, further. The more and more we add to it, and what we ended up building was we used, instead of using a microcontroller, we used a microprocessor, which is this Intel Edison module. It was very, it was very popular back then when it came out. And Intel Edison, it's a microprocessor with a Linux system inside. So the good thing is that I can, we can install a web server. Our Bionic hand can now have a website on its own, hosted within this microprocessor. So and that's what we did. We built a web server within this system, and the rest of the boards that you see, those are the control boards and everything. Then we had the Bionic hand ready. This time we didn't use DC motors. We used servo motors so that you have more precision. Then we had all the power supply, everything worked out, and I'll just show you how big the power supply is. So this is a power supply. It's a very big power supply that will put out around 6 ampere current and 12 volts. So it's a really powerful one compared to what we had for the first, Bionic hand. And then once we build everything up, if we turn on the Bionic hand, what we can do is turn on the Bionic hand, then it automatically gets connected to your local Wi-Fi. And if your laptop is also connected to the Wi-Fi, you can go onto your Chrome browser. You can type in an IP address 192.168.0.10 or 100, the IP address of this Bionic hand, microprocessor, and then it will open up a web page over there. And the web page will show you what are the different templates that is already there in the Bionic hand, and then there you have a marketplace. When you click on marketplace, you will have additional templates that you can add in. So we had a bunch of things back then, and one of the things that we added was rock paper scissors. So that was just added in just to show what we can do with it. So normally it's just thumbs up, open, close, and all. But what if a person using the Bionic hand wants to play rock paper scissors with another person using his Bionic hand? So we had a template just for that, where if you twitch your muscle, you can ask the Bionic hand to either randomly put out rock, paper, or scissors, or you can control whether it has to show rock, paper, or scissors. So that's what we had. I'll show you a video of it, and those were the kind of things that we started experimenting on. And that was the whole marketplace idea. So maybe in the future, if someone builds a very crazy thing where you can even play a keyboard or something, that would be crazy. So the reason why we built a marketplace was then you have a lot of different minds working on it. A lot of different ideas will come in, and eventually, just like the name suggests, the Bionic hand will evolve as such. So that's the whole thing, and we built everything out, and then we started also working on the EMG part. And this is the EMG circuit that we built. It's a very small one, and if you look at the soldering, these are very tiny components. It's a 0603 component, that's what you say. And we had no idea how to solder these tiny components. So the only way to learn it is not by looking at YouTube videos, just go ahead and do it. At least that's what we do. We just built it. Even while this, this board was being built, we had no idea how to, solder the thing. So we got the board, we invested a bit of money, we got the board, we, sourced all the components, and then we started soldering. So because we know that this is the first time that we are doing it, we had 4 additional boards and more additional components. So we burned through a lot, but then eventually, right now, we can, I personally can solder really well. Yeah, sure, Nantata. I'll show you the parts. So I think I'll just quickly, finish this off, and I'll show you different parts of the Bionic Hand. Thanks for that input. So, so this is the EMG circuit that we built back then, and how the EMG works is there is, so you have seen those ECG, ECG electrodes that gets put on your chest when you go and see a doctor and wants to take an ECG. So those electrodes will get attached to your muscles and to a bony area, and that will get connected to this circuit. The circuit is hardwired to a Arduino analog input, and the analog input will able to, whenever I, actuate my muscle, the analog input will show a spike, and which means that a signal was captured and amplified and passed on to the microcontroller. And once we get it to the microcontroller, then it's pretty easy. I can just say that if the value is above this, activate the finger. If the value is below this, don't do anything. And even if there is 2 spikes coming back to back, I can say that wait for 1 second. If there are 2 spikes, it means that it's a different command. Maybe do a different pattern or something, do a different template or something. So the control part was also done. It wasn't as good as we wanted to be, but it worked really well. Once the control part was then done, we went ahead and as I said, this was completely wired. We went ahead and made a completely wireless version. It's a bit big. It's because we have a so this is a bare PCB. I couldn't find the actual one. So it had a wireless Bluetooth. It had a bunch of different components, and this is something that you can attach to any muscle, and then it will wirelessly connect with the Bionic Hand, and then based on the, how the programming is done, the Bionic Hand will get activated. And once this was done, we wanted to do one last thing. Remember how I told you that we had this pressure sensor to understand what is the pressure that gets put on a object. The thing is, a pressure sensor has a lot of different problems. Like even in this particular hand, you can see that there is only one pressure sensor. So what if it's a if it's a weirdly shaped object? Maybe the object won't even touch this particular pad. So in that case, you need to add a whole lot of pressure sensitive components to it, and even if one of them goes bad, then your entire pressure sensitive concept is, or that logic will get flawed. So we wanted a better way of understanding what is the pressure that is being put on. Now what we did was, here's where I really love the way in which we did do things, because the obvious choice was add a lot of pressure sensors, but that would be over-engineered in a sense. We wanted to correctly engineer it, and this is what I say to most of my juniors. You have to, when you're building something, you need to, if it is priced really well, that means it was engineered really well. So even if you go to my LinkedIn, you'll see that I've said, if you can price it right, you have built it right. So that's something that I take very close to my heart. And I'll tell you what I mean by that. So the problem was that to understand what is the pressure that is being applied on an object, and without even giving a command to the Bionic Hand to stop closing, the Bionic Hand should be able to do that, automatically. And so we thought that the best way to do that is to figure out if we, and how do we do this. So that's what we did. We went back and looked at how we do it, how human beings do it. So one way in which I can say that is, when I'm holding this Bionic Hand, say if someone is going to push it down from here, the Bionic Hand is going to slide down, right? So just consider this as any daily object, like let's say it's a bottle.
if I'm not applying enough pressure, it will just tend to slip down and then fall off. So we said, okay, we'll go ahead and build a slip sensor. Now, how do you build a slip sensor is the biggest question. You can again have a lot of, pressure sensors and whatnot to detect if there is a slip or not. But then we wanted a very cost-effective, very simple single sensor kind of a thing. And what we ended up using was a completely different sensor that is used for a totally different purpose. And that sensor is this thing. So it's a mouse pointer detection sensor, this one right here. And what does it normally do? When you move your mouse on a plane surface, it detects, it tracks in XY coordinates where the mouse is moving, and then it moves a pointer, right? So what if we put the sensor on our hand? And if an object is there, and if the hand is trying to hold it, and if the object slips down, it's like you're moving a mouse pointer, and we can easily get that and coded. We can detect that, and then I can code into the microcontroller and ask the microcontroller to keep closing unless there is no slip. And this, we were really proud of this implementation. And I still remember when we were invited to San Francisco to present the Bionic Hand, there was this maybe 40, 45-year-old Intel guy who had this, who had this really big monster truck kind of a thing. He's a veteran, you know it. Monster truck kind of a thing. And I was explaining this to whoever was coming over there. So this was this very big event, Intel Maker Fair. I don't remember the actual. Oh, Intel Developer Forum. So a lot of people were coming in. I was explaining this, and he was standing right next to me, and he was like, "Yeah, that sounds cool. I can then." So you're saying that if you can track it using a mouse pointer sensor, then maybe I can also use it under my car, so that I can track how the distance that my car has traveled, rather than the traditional way of adding hardware sensors, Hall effect sensors or something. I was like, yeah, that's possible. That was a nice feedback. He complimented in a way, and I was pretty happy about it. And that's something that I was proud of when we built the. That's one of the things that I'm proud of in our second Bionic Hand implementation, and that's what I meant. So there were two ways of an expensive way of doing it, a traditional way of doing it, and there was a different way of doing it, which just reduced the cost like anything. And you would see this if everywhere, if you there is a 2010 Steve Wozniak, who is the co-founder of Apple. You might already know this. So there is a 2010 talk by Steve Wozniak where he talks about him doing engineering something totally different. For example, this was a time when back when they were building Apple, that was a time when color televisions were coming up, and then building a system that can output color was a huge, humongous task. You have a whole lot of electronics to it. But then what Steve Wozniak did is he had a very different way of approaching it, where he did it for something under $1, using a chip that would just cost $1. And he had a lot of sleepless nights. And then he said he was in a different state when it just struck him that, okay, if it's a sine wave, if I do these things, maybe I'll get a green color, maybe I'll get a blue color. And that's I don't want to spoil anything. You can just go ahead and watch that video. It's a pretty good one. So at least for me, engineering is more of innovating. And this is what when I talk about innovating, this is one way of doing that, finding some really simple way of solving very big problems. And so we ended up building the Bionic Hand, the second version of it. And okay, my time is almost out. So we ended up building the second version of our Bionic Hand, and we pretty much finished it up. We had a lot of awards and accolades coming in, and again we had to stop for a bit. In another 1 or 2 years, we would come back again, and we would start working on something much more focused. So on a part that we personally think that we need to nail in order to build a really good usable Bionic Hand. So that's what we did almost a year back. So I'll finish with this one, and as earlier, as I said earlier, I'll just show you a couple of different parts. So a year and a half back, what we did was we started revisiting the Bionic Hand again because we were getting enough time. And the first thing that I personally wanted to nail down was the control part. So you know how EMG is not the best, at least right now, it's not the best way to control it because you just have two, inputs for 5 fingers. So so the concept was, how do we build a gesture recognition unit that will detect gestures and then translate it to the Bionic Hand. And that's when the Elixir, that concept came up. And the funny thing is, you know how I came to know that this technology exists. A year before that, I normally have a very good relationship with my juniors. So a lot of them would call me up, sometime, and then they would talk about their seminar. And then there was this girl who called me up, and she's a very good friend of mine. And she called me up, and she was talking about this technology called electrical impedance tomography, and I had zero idea what that is. And I said, yeah, it sounds good. Let me have a look at it. And I ended up learning the entire EIT IEEE paper that I could get my hands on, and it was so, it was a revolutionary thing for me. So electrical impedance tomography, it's a tomography technique. So a simple way to put it is, in X-rays, you have X-rays going from one side, and then you have a plate where and you stand in between, and then based on X-rays that is absorbed, there is an impression that left over there. Now, electrical impedance tomography does the exact same thing, but it uses electrical impulses, and you can just go online and read all about it. So I don't want to get into the details of it. So I ended up learning about this EIT, and this is not a new technology. It's been there since 1970s or 80s, and we actually use EIT to map for neonatal, so for newborn babies. They use EIT too, because for newborn babies you can't do very strong X-rays and MRI scans, so they
use EIT. So then fast forward a few months, we started working on this concept called EIT. We started working on sorry. Sorry. Okay, so we started working on EIT. We ended up building gesture recognition.
So the beauty of that device is it is a band, which you can see over here. So it's an 8 electrode band. So you have 8 electrodes, and all you have to do is you have to wrap this around your wrist like this, and then we designed an AI model that would interpret all these EIT signals, and
and we would be able to train that model on different gestures. So I would do this gesture, I would train the model, I would do a different gesture, I would train the model, and I would do fingers individually, and I can train these different gestures to the AI model so that when it starts predicting, whenever I do a gesture, it just gives the right output. And the best part is that EIT, this particular band doesn't even care if it is put on the wrist or on the muscle. For EMG, it does care. You have to put the EMG sensor over here, and you can't put it over here. And Elixir, even though we started it as a gesture recognition device, it evolved into a completely different thing. But then what this gives us is, using Elixir, we can build a gesture recognition device right into the Bionic Hand that will be able to actually individually actuate each of the fingers. So that's what we focused on. And even right now, that's what we are focusing on. But the second thing that we are focusing on, our next iteration is, if you see these fingers that we have built, it's just a nut and a bolt. There is no, and by the looks of it, you can see that there is friction over there. And even in the 3D printed part, you can see that it's just a nut, a screw that is going through. And this is bad because if you don't, because there is a lot of friction at the joint, so that the motor has to work extremely, the motor has to take more power to actually actuate those joints. So right now, what the first thing that I'm going to do, So I'm trying to find some time, and the first thing that we'll be doing is not build the entire Bionic Hand, just build one finger that works phenomenally well. One finger where the joints are all, these ball bearings. And there is a whole bunch of way to do it. And the moment you put ball bearings in, there it becomes more smooth, and there is a more natural way of opening and closing. And then also learn about the physics of how you open and close your finger. So you don't do the robotic thing, right? There is a rhythm to how you open and close. So that's another thing that we want to really nail down on. And then of course the EIT part. So this was the initial EIT breadboard thing that we built. So this is the breadboard wiring, and then we have an ESP32 over here that would, send all the data back to the microcontroller. And you can see that this is the actual main signal conditioning IC. These are just multiplexes. And then we have everything wired together, and even there is a whole design going for it. Now, I'll conclude by saying, just give me 2 more minutes, I'll conclude it. So, you might say that if I want to build something like an EIT module, I have zero knowledge on how to build it. I don't have your experience. The point is, it's not about experience. The data is already out there. If you say that you don't have experience, it's just because you haven't done anything. So how did I get the experience? I just started working on it. I had zero knowledge on what EIT was, and this person informed me that there is something known as EIT. I just went ahead, read through a bunch of IEEE papers, and I just built the first EIT circuit. And to build your first EIT circuit, the data is already out there. There is a bit of designing going on, and where do you get the design? It's there in the data sheet. So in the information out there, they'll tell you that these are the ICs that you have to use. And if you look at the data sheet, there might be like 2 or 3 equations that you need to solve with all the inputs right there. As an engineer, I've gone through worse. I've done my BTech and MTech, and I've gone through worse. The number of series exams and the number of equations and all those things that I've gone through, 4 pages of a data sheet is nothing in front of me, to be honest. So it should be nothing in front of you as well. So that's how you get experience. That's how you learn things. They need to, rather than thinking about, what are the things that I need to do, and, just planning the hell out of it, just go ahead and start doing it, just don't keep on ideating, and at the what ends up happening is that you have 3 months, you keep on ideating for 2.5 months, and in the last 15 days you'll just mug up something, and then you'll call it a day. Very bad way of doing it. So one thing that I can do is I can always help you out whenever I can to give you small insights into how to build it, but I would always say that consider engineering as a tool. It's kind of like a huge superpower. Forget all the trolls and everything that comes in about BTech and MTech and all the education system. Forget about that. Engineering is kind of like a tool. So if your passion is into music, of course you can engineer some really good things into music. You remember how A.R. Rahman, for that Intel show, he used air drums using Intel Curie. So this actual EIT module was initially using an Intel Curie chip. So A.R. Rahman's passion is in music, but he teamed up with engineers to create air drums and air guitars, and that's engineering. So it's kind of like Photoshop. So if you know how to draw, then if you also know Photoshop, then you have the whole digital world of art waiting for you. And if you are a musician and you also know engineering as a tool, or if you are into farming, let's say. So right now I'm working on a robotic farming thing, because clearly I don't have enough time to set up a good farming thing over here in my house. Mom and dad takes a lot of effort to maintain what we have. So I wanted to completely automate the entire thing out. I am putting in cameras to see if there is any disease, to see if any flies or anything is coming in and creating havoc, and then provide nutrients properly. If the temperature is going up, cool down the entire system. So I have a whole robotic farming thing going on right now, and that's just my side project. So I have a company, even while I was doing my BTech or an MTech, or as a software engineer in a Pakka Infosys kind of a corporate thing, I was still working on electronics project, because engineering essentially gives you superpowers. You can control a whole lot of things. I can just automate my entire room. I don't need anyone else. I can just retrofit everything that I need. The only thing that I'm not doing, only reason why I'm not doing it is because I want to put that effort in something like robotic farming and bionic hand. This is something that I know that I can do. Maybe it'll take a week for me to automate it completely. It's not a big deal for me. But bionic hand, cracking that, robotic farming, cracking that part, that's interesting for me. So if you are not a person who is not interested in engineering, mainly because of how it is being portrayed to you or your experiences at college, try to step back and think about it again. If you are a person who thinks that I have zero knowledge, zero experience on building something this big, remember how we started with the Bionic Hand and how crappy this particular thing is. It literally falls off right now, and where we are right now. So experience, just like the word, it you have to experience it. You have to do it and learn it. You have to fail and then do it again and experience it. So that's how I got into Bionics, and I hope I'm clear on the fact that you can also get into Bionics, you can also work on things, but then you got to start doing things rather than just keep on ideating and putting nice little words into a let's say an abstract that you have to submit at college. You have to start working on things. Everything will fall into place. Just one last thing, because I talked about the mark part. My batch got the highest, for highest marks for mini project, and it just it was natural for us. Even if we get something like 80 or 85, we were happy with it because we were doing something that we loved, and it was so freaking awesome. And the marks never, or credits for that matter, it never bothered us in any way. Anyway, things will fall into place. Try to take a bit of risk. Try to go ahead and do things and experience things, so that over the next 2 or 3 years you can be a better engineer. And always reach out to us, reach out to your seniors. We'll be happy to help. It's just that we have especially because we are running a company, there's a lot of time constraints, but we will connect with you. So just reach out on WhatsApp or over phone. We will connect with you. Even yesterday night, I had a 1.5 hour call with one of my juniors who is in UK right now. He wanted some help, and that's something that we do. That's the reason. Even right now, I am supposed to be working. That's the reason why I'm coming back to you. And remember that you have to do the exact same thing for your juniors. Help them out, because your seniors are the ones who have industry experience and who can help you out properly. Okay, I'll conclude by saying that if you have any questions, shoot out, and if you want to see any specific parts or talk about, you want me to talk about it, just let me know. All that if we have time to do it. So, Leni ma'am, sorry that I took another 10 minutes.
Oh, that was great, Sanju. And we really should say that Sanju's batch was a really good team during the time they were here. So thank you so much, Sanju, for keeping on and keeping in touch with our students even after you've passed out from BTech and then later from MTech. Okay, so thank you and keep up the good job.
Thank
So
you, ma'am.
if anybody has questions, you can ask Sanju now.
Yeah.
Deepti, you can take over.
Yes. So participants, if you have any questions, please feel free to ask. He's a very friendly person. You all know that.
And don't shy away from questions, like even if it is a very, very basic question. It's fine. That's how we learn. Or else, ma'am, I can conclude by showing them a couple of videos if that is okay. Do we have
I
another?
think uh, I think because it's 12:30 now. So
Okay.
can you send me the links? I can share it
Yeah,
with the
the thing is, those were videos that we
yeah.
took, on the fly, and it's not
Oh,
edited properly.
all right. Okay, okay. So
Yeah,
what should
then
we
it's
do?
fine.
Okay, I think you can show one video.
Yeah, sure.
Okay.
So I hope you guys can see my screen. Okay, it's coming up. Yeah. Okay. So I showed you the breadboard part, but then this is the final PCB that we have built. It's pretty small. You can compare it with the Arduino board that is there. That's actually an Intel Curie board. Then this is the Elixir EIT thing, and then this is, you might be familiar with the place. It's our IEDC lab. This is just playing rock, paper, scissors with the Bionic Hand. And we were just fooling around taking, and you can see that the EMG part is already attached to my hand. So I'm always, so I'm the one who's controlling when the Bionic Hand has to show rock, paper, or scissors. And we were just fooling around. As you can see from the video, it's not edited properly. We were just doing, a bunch of things. And sometimes it does something, some weird things where we have no idea what's happening. But then we figured it out later. Anyway, so that's one video that I wanted to show you. And there is a touch button over there. So whenever I touch, it keeps changing the profiles or templates. And I'm just testing a couple of things out in this video. So this was right before I think we went for the competition, I guess. So I also wanted to show you a video of the Elixir thing working, but I couldn't find it. Maybe we'll get another. We can. I'll show it to you sometime, some another time, or maybe anyway we are working on a good version. So once that is done, we'll post something on YouTube or Instagram. So that's what we are hoping for. One of the recent things I did with the Bionic Hand, which I'll post to Instagram soon, is so I've placed my Bionic Hand close to my TV so that during weekends, if there is some important emails that is coming in, it already gets connected to my Gmail account, my company's Gmail account, and then it will pull all the important emails. And then if there is, I've marked what emails are important, and then once it figures out there is an important email, it would do some gesture to get my attention. So that's something that I'll post, and hopefully I'll be able to open source that part. But then everybody doesn't have a Bionic Hand, but once you open source it, the Bionic Hand part, you can you can substitute that with maybe a shield or maybe one motor that is just going around trying to get your attention. So that's also something that we have been working on. Okay, I've got a question. Is the arm designed for capability of grasping objects or just control of finger movement? Yes, the arm is designed for grasping objects. So right now, when we design the arm and when we design what are the strings that we need to use, then we design it. We choose the strings and the arm and everything associated with it to make sure that there's a specific weight that we can hold at one point of time. So that's how the entire thing is designed. But yeah, it has a capability of grasping objects. Okay,
Thank
I think
you,
I've
sir.
taken too much time.
No, sir, that's fine. And now I would like to invite Vishnu to deliver the vote of thanks.
Okay, on behalf of all the interns and mentors, I thank Sanju sir for this awesome session. A great Bionics. Thank you, sir. And I led code for sure. Thank you, sir.
Okay, thank you, Vishnu.